Hey, what's up? It's your old pal, Mr. Cook, and we are going to work on the graphs of exponential functions and log functions on the Unit 3 group work assignment, so numbers 9 and number 10. Okay, so I'm going to kind of do these together because a lot of them have the same steps, even though the functions themselves look very different. And it's because it's all tied together with transformations, because with transformations we will see a lot of the same sort of like properties and rules, like regardless of what type of function that we're dealing with: quadratics, polynomials, logs, exponents, whatever. One thing that we can find always is the y-intercept. As long as it's part of the domain, all we have to do is just plug in 0. So if you plug in 0 with your calculator, or if you want to do it by hand, you can do that too, but it's 3 to the power of 0 minus 2 minus 1, and you get that. Then you can turn it into a fraction, and you get -8/9. So there's our y-intercept, -8/9. Asymptotes for exponential functions, you're always going to have a horizontal asymptote, and it's always found by just whatever the number is adding or subtracting on the outside. So the horizontal asymptote is going to be at y equals -1. So you can start graphing that out too. So here's your horizontal asymptote passing through -1. There we go. Okay, the domain for the exponential functions that you guys are going to see in the class it's always going to be all real numbers. The range, so if you just graph it out, you can see the range pretty easily too. 3 to the power of x minus 2, there we go, and then -1, graph. There it is following the asymptote, and then all of a sudden just shoots off into the positive y direction. So the range, it's capped by this like -1, and then it goes up to positive infinity, but it actually just goes along the asymptote line. It never actually gets there. So our range is going to go from -1 up to positive infinity, not including it, so no square brackets, just parentheses here. If you want to write it out as an inequality, it's y is going to be greater than -1, because the y values are always bigger than -1, always. Is f of x increasing or decreasing? Well, if you look at the graph, as it's going from left to right, it's just going up, so it's always going to be increasing. Now, any transformations? Well, that's, the transformations come from the Unit 1 stuff that we learned about, like a times f of x plus h plus k. I think I have a whole, video on transformations from Unit 1. You can check those out if you want. But basically, if you have a number that's adding or subtracting on the x, that's going to be moving it to the left or the right. If you have some number that's adding or subtracting outside the function, then it's going to be moving it up or down. The a value tells you if you're going to have a reflection over the x-axis, or if you're going to be doing vertical stretching or vertical compressions. And then the h value, and the x value also, if you have a negative on the x, it means it's going to be reflecting over the y-axis. So the transformations that we have for this exponential function are that we have a x minus 2, so the -2 is affecting the x value, so that moves it to the right by 2. And then this -1 over here outside the function, which means that we're going to be moving the whole graph down by 1 unit. Okay, and then, from here it's pretty easy to work through this, right? Because since we have our graph, we can just go over to the table, get a couple coordinates from there, and, graph it out pretty easily, like a 2, 0. Okay, so over 2, up 0, there's a coordinate. 3, 2, so go over 3, up 2, there's another coordinate. 1, -2/3, so over 1, down 2/3, so like right there. And then 0, -0.8, repeating, so that's going to be real close to -1. So as you see, the graph is going to go through these coordinates here, and then just go along the horizontal asymptote forever. So it's going to continue on and on and on. So there's our graph, and we just have a couple coordinates to make it really accurate, and we're good to go. For number 10, same stuff, just write out your transformations and all that garbage, so it's pretty easy. The only weird thing is that when you plug in 0 for your y-intercept, you're going to get like a funky looking decimal value. So let's see what that is. So if I type that in, we get log base, let's do that one. Okay, so log base 2 of 0 plus 3, and then -4. Oops, why'd I hit graph? Enter. And then I get my intercept, which is going to be -2.415, so I don't know, 0.42, whatever. Just graph it best we can. With log functions, you're gonna have like an asymptote value, a vertical asymptote, because this whole thing, it has to be positive only. Like your x plus 3 can only be positive, so it always has to be greater than 0. So like to find the asymptote, let's find the domain first. So this is how you find the domain. You just take whatever function you have in here and make sure to strictly say that it has to be greater than 0, and then solve for x. So if I subtract 3 from both sides, I get x has to be greater than -3. So that is my domain. X is greater than -3. And, you know, writing it up in interval notation, it starts at -3, and then if it's, you know, all the x values are bigger than that, then it goes up to infinity. So there's our domain. The range for the logarithmic functions, like all the ones you're going to see in this class, are always all real numbers, so you can just write it up like that. Now the asymptote, what happens is that the x values just abruptly stop at -3, so that's why that makes this an asymptote. Your x value at -3, there's some weird stuff that's going to happen there. Okay, so just draw your vertical asymptote in there. You do have to draw in your asymptote, so make sure to draw those in. Is f of x increasing or decreasing? I don't know, let's graph it out in a second, but let's say the transformations. X plus 3 means that it's going to be moving to the left by 3 because it's affecting the x value. Remember, x goes left and right. The -4 on the outside of the function is going to move the whole graph down by 4 units. So those are the only transformations that we're going to have for these ones. Make sure to watch out for negatives because, again, those are where you're going to have your reflections and things like that. Okay, so let's graph this function out. So just for everybody's sake, I'm going to graph it out not using log base, but just using logs. But I'll show you how to graph them out the same way on the 2 different lines, just in case you need it, okay? So what we do first is just the regular log. So we could have log of x plus 3. And then divide that by the base, which is log of 2, so log 2. And then -4 at the very end. So that's, you know, that's one way to graph it out. The exact same equation written out using log base looks like this. So math, and then go to log base 2 of x plus 3, and then -4 at the end. And you'll see these graphs are identical when you hit graph. Here's the first one there. And then the second one. See, it's the same thing, same exact graph. All right, so let's get the table now. All right, so a couple coordinates, let's see here. So -2, -4, okay. -2 and then down 4, 1, 2, 3, 4. And then -1, -3, so -1 down 3. 0, well, let's do 1. 1, -2, over 1 down 2. And then 5, -1. 1, 2, 3, 4, 5, and then -1. Okay, so a graph like goes through these points, and here's an important thing that you might not have noticed, all right? On your graphing calculator, it just kind of stops right there, but actually what's going to happen is that this graph is going to continue to go down along this vertical asymptote forever. So make sure that you account for that. So look on your graph real close. This just stops. It's because your calculator can't handle the fact that it's more or less a vertical line drawing down straight from there. So, you know, don't just stop your graph there. I'm sure that we're going to take a point off if we see that on a test. So make sure that you account for the fact that we have a vertical asymptote there. But once you have that, you have a couple coordinates, you've got all this information, and it looks from left to right that over the course of the domain of the graph, then it's going to be increasing the entire time, for the duration of its domain. All right, so that's some graphing problems. If you need more help with graphing, we have a bunch of example worksheets that you can find on Schoology along with the solutions for those. So make sure that you look for those online. All right, that's it for this video. Now we're going to go into the word problems.